So question 6 is about analog and digital signals, and if you're at all stuck on analog and digital, take a look at the P2 revision video, because that one is about analog and digital. But just looking at this, here's the question. We've got the graphs below show two digital signals. In each case, the first two codes of the signal are 1 and 0. So we've got a 1 and then a 0 here, and a 1 and then a 0 there. The x-axis, the time axis, are drawn to the same scale, and the y-axis, signal intensity, are not to the same scale. That's going to be important for a later question. So why is the scale on the y-axis not important when decoding these signals? Well, the whole point about digital signals is, in binary digital signals, is that they're either 1 or 0. So you don't really need a scale, you've just got a high and a low value here, and whichever is the high one will be 1, and whichever is the low one will be 0. So you do not need a scale, because that's the only two choices you've got. Okay. Describe the differences between signal A and B. Its difference is plural, and there are 2 marks, so almost certainly you're going to need 2 differences. Probably the most obvious one is that the signal B has this sort of wiggly nature to it. Now you need to know the right technical term for that, and that's that the signal B has picked up noise, or is a noisy signal. Noise doesn't mean sound, it just means these random additions to the signal, and this happens whenever you transmit any signal. You just get random interference that adds noise to the signal. You can't get around that. You can reduce it, but it's always there. So noisiness is 1, or noisy on signal B. Make sure you say which signal is noisy. And the other thing, and this is where we've got to be careful, right? We can't make any comparison about the signal intensity because it says they're not drawn to the same scale. So we don't actually know which one of these has got a higher signal intensity because of this statement here about them not being to the same scale. But we do know that the time axes are drawn to the same scale. And what you can see is that signal A is changing more frequently. In other words, the 1s and 0s are closer together in time on signal A. And what we say then is that it's got a higher frequency, or it's transmitting more bits per second. A bit, remember, is just a 0 or a 1. It's the name for the 0 or 1 that we use in binary code. So those are the 2 differences. And the final part of the question here, radio waves and infrared radiation are used to transmit signals in different circumstances. Describe and explain the different circumstances in which these 2 regions of the electromagnetic spectrum are used to transmit information. So again, this is a recall question, but lots of people miss out the explain part. Okay, so you need to do the explanation, otherwise you get 0. Because if you look at the mark scheme, there is 1 mark for the radio part and its explanation. The word because is underlined to show that we have to have the explanation there for the mark. And 1 part for the use of infrared and its explanation. So radio waves, hopefully we know, are transmitted through the atmosphere, and the reason for that is that the atmosphere doesn't absorb them. Whenever you're trying to transmit signal, you don't want the thing that your signal is travelling through to absorb that signal. That would be rubbish. And similarly, infrared is used in optical fibres because the glass or plastic in optical fibres doesn't absorb the infrared. And it does note in the mark scheme here that you can talk about infrared for remote controls, and the reason that's important is infrared over long distances in the atmosphere would be absorbed, but over the distance across your living room, there's not enough absorption to stop the infrared signal from your remote reaching the TV. So you'd need to include an explanation like that to make it work.